Well, good afternoon, everybody. My name is Mark Orr, and I'm the Executive Director of the UK and Ireland Spill Association. I'd like to welcome you to this knowledge-based presentation on drill rig selection and safety. I'm grateful to OAMPS Hazardous Industries Insurance, who have provided the funding for all of these events to take place. These are part of our knowledge-based series. And the idea was that when we started this, which was when lockdown hit, was to basically share our members' world-leading knowledge and enable it to be found, accessed, and shared, and as a result, enable knowledge to be increased. Over time, we hope that this will become a place where those involved or interested in spill response may come to inquire, increase their knowledge, understand what good looks like, so that they can work more safely, be compliant with the relevant legislation, and deliver a better service. And so far, I mean, we've now done 10 marine knowledge-based webinars in 2021. We've done 4 inland-focused webinars in this autumn. And you will actually be able to find all of these through our knowledge base area on our website, which is www.ukeirespill.org and in /knowledge base. And you'll be able to find them all there. We're going to be putting a search facility on them so it makes them easier to find because there's plenty in there. And they should be used as toolbox talks. They should be used for training, but basically try and see if you can share the knowledge. I mean, sharing knowledge makes us all safer and better in our work. Now, we run a whole series of knowledge-based webinars. The next one is on the 24th of November, spill response to biofuels, a really, really pertinent subject and the result of a lot of research which the association has done with Oracle Environmental. And later in December, which will be our last of the year, is an inland one based on soil sampling and analysis, and it ties very, very nicely in with this webinar. We're also going to be doing a number of other webinars, which you can see here. Obviously, we've been following the Wakashio. We're waiting for the last bits of the REC to be removed to summarize that. And we hope to be doing one on plastic pollution in the near future. So watch out on our website and on LinkedIn to get more details of that. So turning to today, this webinar is all about drill rig selection and safety. Now, if you have a spill, the likelihood is that you're going to have to use a drill rig. And if you're going to use a drill rig, you need to choose the right one to get the right information from it. And this is really trying to explain the different types of drill rigs that are available, how to use them, but importantly, what considerations there should be around using it. You know, drill rigs, in my experience, drill rigs have been used in buildings, they've been used out on sites, but it's really, really important that before you commission the use of one, that you gain some understanding from the drill rig supplier on what you want them to do, how you want them to do it, what outcome you want, and all the rest of it. Now, I don't know a lot about drill rigs, so I'm looking forward to this. And we've got 2 really knowledgeable speakers who are going to be able to share their knowledge with you. Firstly, UK and Ireland Spill Association board member Rory McKinnon, who works for RSK Raw, and Eric Downey, who's worked with drill rigs for the last, I don't know how many years, but it's certainly more than 10, who works for a company called Structural Soils. And without further ado, I'll allow them to spread their knowledge and share their knowledge with you. And really, it's now time to hand over to Rory. So Rory, I'm going to stop sharing and allow you to share your screen. So thanks very much indeed. And let's hear what they've got to say. Bye-bye. Right. Okay, over to you, Rory.
Lovely. Thanks, Mark. I shall turn my video off because I don't like looking at myself talking. Right, here we go. Hopefully everybody can see that.
Yeah, that's great.
Lovely. Perfect, thank you. Well, firstly, just a quick thank you, Mark, for the kind introduction and for the opportunity to speak today and to be part of the UK and Ireland Spill Association webinar. For For those that don't know, I was appointed to be a board member of the association a few months ago and to represent the inland spill and consultancy element. I have around 15 years experience with oil spills and pollution incidents for RSK Raw. And prior to that, for a large environmental consultancy. So in technical terms, I've got shed loads of drilling experience, I think is the technical phrase. I thought it'd be a good idea to use today to talk to you about using drilling rigs, some of the questions to ask, some of the things to look for before deploying a rig. So without further ado, I shall skip on. So depending upon your view, these documents are either the most interesting or the most tedious part of drilling investigations. However, whichever way you lean, these are the fundamental documents that provide guidance on the requirements of investigations in contaminated ground. Every single skilled ground investigation practitioner must be familiar with these documents as they underpin every element of our work that we undertake. These aren't the only ones. There are multiple other documents that also relate to ground investigations and kind of supporting documents for these. And a lot of them are detailed within these documents themselves. So where does it start? Well, it starts at your conceptual site model, the CSM. The conceptual site model is a representation and/or description of the site, incorporating all that is known and anticipated about the site, such as contamination, your geology, pedology, environmental setting. It should identify the pathways by which the current and future receptors could be affected by the contamination. And an important aspect of the conceptual site model is the formation of contamination-related hypotheses. Gotta love it. Note that its preparation requires some interpretation of the available information and explicit recognition of the uncertainties in that information. The development of a conceptual site model can aid greatly in the understanding of the site and the risks it might present to human and other receptors, as well as the design of future phases of investigation. It also aids in the decision on how investigations and, if required, remediation may be achieved. A conceptual model is usually presented in a tabular, textual, or diagrammatic form and can be as simple or as complex as required. So here we've got a relatively simple CSM, which clearly shows the source of contamination, the oil drums, the pathways present and the receptors. Using the CSM in this way allows the reader to easily visualize the reality of the situation and aids in the communication of the pertinent issues between different parties. Sorry, could everyone mute themselves, please?
Yeah, good idea.
There's a lot of feedback.
Kev Bond. Can we mute Kev?
I don't know if I can mute everyone.
I think Kev Bond is the one that's giving a little bit of feedback.
There we are. Perfect. Thank you. Thanks, Kev. So the CSM also allows the contaminated land practitioner to, if required, design a suitable ground investigation, the crux of today's presentation, in order to further assess and or remediate the identified risks. So, using these CSMs allows you to start designing your drilling investigation by collating the data you've obtained to date and taking other things into consideration, such as the orientation of the spill plume, geology, groundwater depth and flow direction, to name but a few parameters. They can also be used to show more complex sites in a simplified manner that is easier for everyone to understand. Here, for example, we've got multiple geological formations that have been identified during the investigation works, with both light non-aqueous phase liquids, LNAPLs, and dense non-aqueous phase liquids, DNAPLs, delineated within the different geological formations and within the groundwater. So you see, it just makes it something that could be very complicated to write down in text. You can visualize it very easily by presenting it in a CSM like this. So this CSM is from one of my own projects where the ground makeup was particularly complicated. Only through multiple phases of intrusive investigations using different drilling techniques were we able to identify and fully develop this conceptual model. We've identified areas of made ground contamination, 3 different formations, and 2 discrete groundwater bodies. And hopefully this gives you an idea of the amount of information and level of detail that can be obtained by an appropriately designed and implemented drilling investigation. I have to say I'm particularly proud of that one. So the objectives of your investigations are driven by many factors that need to be assessed on their own merits on each specific project. No one size fits all. One needs to have a clear idea of what you're trying to achieve by undertaking a drilling investigation, and Eric is going to hate me for this, if you even need to undertake one at all. If you need to drill, then you must ensure that by doing so, you're not going to cause a bigger issue than already exists. For example, by drilling a hole to groundwater, are you going to create a pathway by which the contamination, which you're trying to delineate, can then rapidly migrate vertically into that groundwater? If so, then perhaps it may be better to stop the borehole short of groundwater after bottoming out the contamination in the unsaturated soils, or maybe relocate the borehole outside of the area of your known contamination. If you aren't sure how best to proceed, then please feel free to give me or one of your friendly drilling contractors a call to discuss. The better the planning for a drilling investigation, the less chance there is of a costly mistake being made, and the higher the quality of the data obtained. So, you decided you need to undertake a drilling investigation. What next? There's lots of considerations that you need to make before you even get to site. You need to determine whether you can safely deploy your selected drilling rig to the site, because wouldn't it be embarrassing to spend all that time and money mobilizing to site only that you can't actually get the rig down the side of the building because the access was too narrow and you hadn't measured it? The following few slides touch on some of the areas that are worth considering and should form part of your pre-start meeting with your preferred drilling contractor in order that you can plan your works properly and safely. When you arrive on site, it's always good to walk the route from where the rig will be dropped off by the transport to where the locations are proposed. If in doubt about openings, measure them. Simple. If you can find out the dimensions of the specific rig and any equipment, such as compressors that are due to be used on the site, then that can aid in your decision making. But the access limitations you find on site may ultimately determine the final rig used. It's also worth thinking about changes in slope that will cause the rig to tip forward or backwards that could increase the access height required. For example, the top left-hand photo there, we can see the drilling rig passing through an opening into a building, and the floor level inside the building is lower than the outside level. As it runs in, it tips the rig forward and it brings the mast fairly close up to the overhead lintel. Fortunately, we were prepared for that. It was expected and all planned, and there was no damage caused, but it was still a very close run thing. Also, don't forget to look up as well as down. Overhead cables can result in borehole locations having to be abandoned if the mast of the rig is too close to the cables, and can on occasion scupper any chance of being able to crane a rig into the site. Access into the house in the photos here, the top left, bottom left, was only possible by removing the sliding doors and threshold to give us enough head height to get the rig in. The rig mast could only be accommodated inside the building by excavating the floors and removing a section of the ceiling, which were undertaken prior to mobilizing the rig. One of the more snug locations that we've investigated. Sometimes it's not just the rig you need to consider, it is the lorry that it's delivered on. Is the gateway wide enough? Look at the road leading up to the gateway. Is it a sharp turn into the site, making access more difficult, or a straight shot through? There might be enough room for the rig, but what about the telehandler that is used to move the equipment around? Is a narrow country lane going to be blocked during the delivery and or operation of the rig and equipment? Do you need a banksman or traffic control measures to ensure the safety of the road users as well as staff and contractors? All things that you should be looking at in your site visit. Drilling rigs can be very heavy. Despite their tracks, they can cause damage to soft or fragile ground. And bear in mind any changes in the weather, such as rainfall that can turn a grassy field into a bog, or hot weather softening tarmac that can then be more easily damaged. What protection measures can be utilised? Well, there are things such as track mats that you can see in the bottom right image that are very useful, amongst many other solutions. However, ground protection can be very expensive, both in higher costs and in labour to deploy and recover at the end of the work. So please ensure that you allow enough in your costs for doing so. We quite often see plyboard used for protection, and in my opinion, it's not ideal as it becomes slippery when wet and muddy and can warp, leading to the creation of trip hazards, irrespective of the ecological question mark of its subsequent disposal at the end of the work. You may need to identify an easily accessible and suitable staging area with your client or landowner, maybe somewhere slightly remote from the drilling area. Ensure that the area is fenced and appropriately signed to prevent unauthorized access and allow enough room to work safely. The size of the staging area will be dependent upon many factors, including quantity of installation materials, as you see in the top left, and any additional plant and equipment needed for the work. Rotary drilling, for example, uses air compressors and water bowsers, as well as various sizes and quantities of containers for storage of and recovery of the flushing fluids. Telehandlers are often used for moving large pieces of drilling equipment around a site, but they need somewhere to be parked safely when not used. Consideration also needs to be given to the location of a skip or stockpile for soil arising. I'm sure everyone's familiar with buried services. Allow enough time to order plans from a relevant service provider or use a dedicated service plan provider and clearance contractor. Service strikes are one of the biggest hazards faced during an intrusive investigation. A service strike could be fatal to the operatives and anyone walking nearby, or at the very least, very expensive for the company in repair costs, fines, increased insurance premiums, and bad publicity. Waste is going to be generated during the course of drilling works, and you must consider what to do with it before you arrive on site. As I previously mentioned, a suitable staging area should be agreed for skips or waste drums with adequate fencing, because there is nothing more frustrating than arriving on site to find your skip full of people's sofas and fridge freezers. Waste should be segregated, as usual, into appropriate streams and disposed of via appropriately licensed waste treatment facilities under correct duty of care documentation. Determining the likely conditions will be part of your CSM, and hopefully you have already completed this at desk study stage. If not, you must do this before you even consider putting a rig on site. There are many different sources of information, and you should utilize as many as is required to adequately inform your investigation plans. No one size fits all. At the very least, I would suggest a geology search, a hydrogeology search, and review of publicly available local borehole records, because the information gleaned from these sources will likely have the biggest impact on your proposed drilling works, the type of drilling rig, and the methodology that you use. Now, drilling rigs. I've grouped them into three main groups, and I'll just touch on them very briefly here. So we've got mini dynamic sampling, cable percussive, which are also known as shell and auger, and rotary or multifunction rigs. And I'll just touch on these briefly over the next few slides, and Eric will discuss them in a bit more detail later. Mini dynamic sampling rigs. These can be handheld or tracked and generally undertake window or windowless sampling. There are discrete differences, but I won't go into them here. In the industry, they're generally known as window sampling rigs. They're great for shallow investigations in soils and unconsolidated deposits to depths of about 10 meters, and they're great for soil logging and sampling. They can access relatively restricted areas, including indoors, and are at the cheaper end of the scale for drilling works. They do, however, struggle with consolidated deposits and can be very noisy. The weight that is repetitively dropped in order to drive the sample tube into the ground does drive some people to distraction. Cable percussive, or as known as shell and auger. These rigs are usually towed behind a 4x4 and maneuvered into position. They're great for deep investigations of soils and unconsolidated deposits to depths in excess of 30 meters. They're great for soil logging and sampling and are accurate for identifying groundwater strike. They do struggle with rock, but can chisel away slowly, and they do require a reasonable amount of working space. So rotary and multifunction rigs are the do-it-all of the drilling world. They're self-propelled, but they are very heavy. They're highly versatile and can often undertake multiple different drilling techniques, quite often on the same borehole. They're great for fast, shallow and deep investigations in soils, unconsolidated deposits, and rock to depths in excess of 100 meters, depending on the rig. They're variable for soil logging, as it depends on the technique being used and the amount of the type of arisings that are generated. Identifying groundwater strike can be difficult, and you need to ensure your desk study information is as robust as possible to aid you in this regard. They do require a reasonable amount of working space, and with your back turned, can create more mess than any child could hope to in the same time. They also have some of the highest mobilization and day rates in the rig sector. All of the above rigs will create noise, vibration, and dust. Some are worse than others. Adequate risk assessments must always be undertaken, and appropriate PPE and control measures must be implemented. Related to the previous slide, dust generation from rotary rigs can be controlled. They utilize different flush mediums to assist and speed up the drilling process, and changing from an air flush to a mist or a water polymer flush can reduce the amount of dust generated. However, they do bring their own challenges. Flush mediums generally require larger work areas due to the additional equipment required and the potential mess that can be created. Using a flush can mobilize gases or VOCs, create aerosols, and potentially force the contamination that you're investigating into previously uncontaminated strata. Have I mentioned the mess before? Do not underestimate the amount of mess that can be created in an incredibly short period of time if adequate containment measures have not been implemented and/or the flush has not been controlled properly. Casing. During drilling, usually in the top sections of the borehole, casing can be used to prevent collapse of any loose material back into the recently dug borehole. Casing can also be used to separate different formations and can be sacrificed and left in situ. Casing is a larger diameter than the bore being drilled, is heavy, and on occasion can be incredibly difficult to remove from the ground. However, without it, many boreholes wouldn't even make it past the first couple of meters. Whilst it's a frustration, it's very, very useful. On occasion, we need to drill through contaminated materials and into clean substrata or groundwater. And that's where this environmental drilling comes into its own. Environmental drilling involves the drilling of a large bore to the initial required depth, i.e. to the base of the contamination. This large diameter bore is then grouted. A small diameter bore is then utilized to drill through the grout and take the borehole to the final required depth. This methodology is often used when changing drilling technique, passing from one formation to another, particularly with different permeabilities of the formations, or passing from contaminated materials into uncontaminated materials. It is used to prevent cross-contamination between formations and/or groundwater bodies. This is a highly specialized area of drilling and incredibly easy to get wrong. The engineer must have a good understanding of the geology and hydrogeology, as well as the contaminant being investigated, as well as the objectives of the investigation. So soil logging and sampling. This is a mandatory element of drilling works. You need to gather the data from the arisings in order to provide a record of the ground conditions encountered and to feed that into your CSM and ultimately your risk assessment. Soils, as always, should be logged to BS 5930. And timescales and costs aside, there is no such thing as too many samples. I'm not saying schedule them all for analysis, although some of our labs would be very grateful for that. Log them, headspace them, record them. However, too few samples and you will not be able to complete an adequate assessment of the contamination or risk. Probably the most critical part of the investigation. The design of these installations will be highly dependent on the geology and hydrogeology encountered during the drilling, as well as what you're trying to measure or monitor. What's your objectives? What are you trying to achieve? Does the installation need to be a metal or plastic piezo? Should it be a 50 mil well screen for groundwater monitoring? Oh, sorry. Or 110 mil plus for remediation. Depending on the contamination or the installation details, are welding fittings required, or welded fittings required by HDPE, or is PVC preferable? Lots and lots of decisions to be made around the installations, notwithstanding the design of them. The use of a filter sock may be necessary to prevent fine sediments entering the borehole and silting it up, but it may then hamper product recovery and significantly impact validation. I'll repeat it several times through here. There is no one standard installation. It's bespoke to every single location. Another question to ask is what headworks are required? A flush fit cover to prevent a trip hazard, a raised cover so the well can be found amongst waist-high meadow grass in the middle of the field in the summer, with an inspection chamber within an inspection chamber to aid with the monitoring and remediation equipment. Each option is site specific and consideration should be given to security, so lockable covers if possible, and longevity. As if groundwater remediation and validation is required, these monitoring points will be in place for a number of years. Upon installation, it is ideal if you can develop the well immediately to remove as much of the drilling fines and flush water as you can to prevent silting up. These are just some cross-section images showing stereotypical installations. Whilst there are no typical installations, they do provide a good guidance on best practice, particularly around locating a well screen and filter packs and small design features that can easily be missed when you're out in the field. Unfortunately, we see too many generic installations of just 1 meter of plain pipe, followed by the rest slotted, the little bentonite seal at the top. That's not good enough. So, in summary, never complete a standard installation. Every installation must be site and situation specific. Never link or install a well across strata, as you may create a pathway that could allow rapid migration of contamination into previously uncontaminated strata or groundwater. If you need assistance, then the Environment Agency have produced a guidance document for the design and installation of monitoring wells. And if you're in any doubt about anything at all, then please ask an experienced contaminated land practitioner or drilling contractor for further advice. I can't stress that enough. Nobody's expected to know everything. So you've got your well in. The well should have been developed. Best practice is also to level in the boreholes or the wells, either to an ordnance datum or to an arbitrary datum for the site. If it's applicable to your investigations and your end objectives, then you can complete a VOC survey of the wells before undertaking your groundwater monitoring. Always dip and record the depth of LNAPL to groundwater to DNAPL and the depth of the base using an interface probe, and always record the measuring point from where you're measuring from. And use that point consistently from visit to visit so that you've got comparable results. You're aiming for representative samples of in situ conditions, and a multi-parameter probe can definitely help with that. So calculate your purge volumes, usually around 3 well volumes, and then record your purge waters to ensure the accuracy of your purging. Depending on your goals for the work, you may not always need to purge. For example, if you record very high VOCs or three-phase product, that may be sufficient for you to determine there is a risk that further work is required. There are lots of different sampling equipment and techniques, and the choice will depend on many factors, but particularly the contaminant you're investigating and the recharge rate of the groundwater. Low flow sampling lends itself to most situations as it minimizes the volume of liquids purged that will then subsequently require disposal, and it suffers from minimal loss of VOCs from the sample. You must consider what to do with your purged waters. Slinging it on the floor next to the borehole or down the local drain is not acceptable. Don't forget to collect your quality assurance and quality control samples, i.e. your field duplicates and trip blanks. So, record keeping of the findings of your drilling works and installation details are incredibly important and will form a very big part of your CSM, risk assessment and your final reports, with the data entered and stored predominantly in these borehole logs. These logs provide a large amount of information in a very small space and allows a really good pictorial cross-section of the geology encountered, installation details of your monitoring well, sampling and screening data that you collected during the course of the work, and any other relevant information you want to add on there. Borehole logs are often requested by regulators and can also be submitted to the British Geological Survey for public record. So do make sure they're good. By comparing borehole logs from across a site, you can often identify the same or similar formations and strata and delineate the discrete bands of contamination. Some specialist borehole logging programs will also allow you to create a 3D image of the site based on the logs. So, you completed your work. You validated the site. What do you do with the boreholes? If they could be reasonably repurposed for appropriate uses, then that is acceptable. However, improperly abandoned boreholes and wells can provide preferential pathways for groundwater or contaminant movement. This may result in the contamination of groundwater, the mixing of groundwaters of variable quality from different aquifers, or contribute to the loss of aquifer yield and water pressure as the groundwater flows out of the system. This can go on and threaten the availability and quality of the groundwater resources for other users. Abandoned boreholes and wells can also represent a physical hazard to people and property. Each situation is different in terms of its location, geological setting, borehole construction, dimensions, hazards, and very importantly, intended site after use. Therefore, the most appropriate abandonment procedure will vary from site to site. No one size fits all. The image in the above slide is from the Environment Agency document on decommissioning boreholes. Despite seeming a very easy thing to do, the proper decommissioning of a borehole often requires a skill and equipment that only a specialist drilling contractor has. So do talk to your drilling contractors about borehole decommissioning, particularly the emplacement of impermeable materials into the base of the borehole to ensure that there's no bridging of that material as it's in place. So in summary, you must develop an adequate CSM and make clear your objectives for the drilling works. The site visit is useful to establish access and setup requirements, and this, along with your objectives and CSM, will determine the most appropriate drilling methodology. There is no such thing as too much information or too many samples, and if in any doubt at all, just record it. Drilling works are relatively expensive, but become even more so if you have to redo them because you've not got enough data from the first round. And as the utmost priority, do not make the situation that you're investigating any worse by creating additional preferential pathways for the contamination. If you're in any doubt about anything to do with the drilling, then please speak to a specialist such as ourselves or Eric from Structural Soils. Thank you all for your time. I hope you found some of this presentation useful, and I shall step back and hand over to Eric.
Well, before you go, Rory, there is 2 questions that you've got. So one from Matthew Renshaw, which I'll be quiz mastering. If you could do the same for me, that'd be very sweet.
Go for it.
In what circumstances might you use a CFA drill stem as pictured in one of your slides? So that's from
one of the slides. So I think we're probably talking.
It was, yeah, up one. It was, yeah,
This
that
one.
one there on the left-hand side, yes.
This one here. Probably a couple of different locations. That one in particular is a hollow stem auger that was used in very loose, almost blowing sands, but loose sands. As you auger down, the arisings come up the outside. You can log them, but it's quite difficult to know exactly where they're from.
That's what I was going to say myself. So I prefer not to. I don't think I probably had it once on site and it was specified by somebody else, but yeah, it's very hard to get a discrete sample. It's great if you're just putting a hole down, but I would not specify that for any contamination because you don't know quite where that contamination has come from or that materials come from. So I think
no, indeed. They're quite useful for installing boreholes in those kind of loose ground conditions. They essentially self-case as they go. The challenge then is removing the drill string without pulling the well installation up and out with it, particularly with blowing sands.
Yeah. Sam Granger has said, as soon as I hear rotary and car parks, I always pack a few extra large dust sheets to cover over cars. Yes. An idiot's very cheap and cheerful thing is some Harris fencing and some visqueen on the back of that. That seems to work quite well, and that's quite effective, certainly. And yeah, chalk is the worst thing ever if you're rotary drilling in a chalk area, because that chalk dust gets everywhere.
Yeah, we're based in I do most of our drilling in the southeast, so we come across chalk an awful lot, and it's challenging.
Catherine said sands and gravels. I think that was for your consolidated and unconsolidated type of question. I'm not quite sure what Catherine, if Catherine wants to jump on to elaborate that. No, she's not. Okay. One other question from Francisco. How can well socks be detrimental to site investigation? Would they prevent LNAPL accumulation in a well?
So socks can sometimes keep a hold of LNAPL. So it can make validating quite difficult because you get residues associated with the sock material. I was always told that it's easier to deal with a silted up well and clear that out using airlift techniques and others, rather than having a sock on it to prevent the fines coming in, but then having residues of LNAPLs. I hope that makes sense.
Roy, I think that was great. Thank you very much.
No
Eric, over to you.
Okay, thank you. 2 seconds. I'm just going to go to the top.
If you can unshare yours, Roy.
Yes.
Yeah, there we are. Stop share.
Right. Let me just share mine now. And here we go. Share screen. Boom. Right. Thank you very much, Mark. And thanks very much, Rory. Can you also hang on? Haven't
Not quite yet.
No, sorry. Sorry, that's all right. Has that?
Yeah, that looks good. It just need to go to.
Yeah, I know. I'm doing
that.
There we go. Sorry. Boom.
That's right.
Right. Yes. Both of you did a fantastic job. I don't quite know what I'm here to do now because you've done such a fantastic job. So again, thank you very much, Mark, for the introduction, and Rory for doing a wonderful job sort of describing some of the things. Please ask any questions as we go along. Yeah, I'm just going to very briefly give you this one slide of structural soils. We are nationwide. We're part of the RSK group, a bit like Rory, and we have a number of offices, a number of bases of operation, and we have a huge number of rigs within our group. So hopefully we can meet your needs, requirements, and timescales, which is probably more to the point than any of the other above. I won't talk about who we work for, but we do contaminated lands. We work for a number of different people. So Rory has touched on investigation techniques, and I don't really want to sort of teach you to suck eggs. However, I just want to go into a little bit more detail than Rory gave about the cable percussion drilling. This is I would typically say for soft ground materials, so we're talking sands, gravels, clays. It's been around since Roman times. It's very effective. Obviously, the Romans didn't quite have a petrol drill or a diesel engine on the end, but they put in piles using this sort of A-frame technique. So it's been around a long time. It's very effective, and it can get through a number of different ground conditions, and it's relatively maneuverable. I will talk about some limited access stuff in a second. We can get down to 80 odd meters if you're lucky in the right ground conditions. But yeah, it's very, very effective. And like Rory was saying, we may have to, depending on your site, you may have to want to get other rigs in, other different types of rigs to give a variety of different techniques on that same site. But what I do want to sort of talk about very briefly is some of the safety features, or one of the mandatory safety features, I should say. The British Drilling Association has now made it mandatory that all rigs, all cable percussion rigs, have what's known as a whip bar on it. And if any of you out there come across a driller that's not using the whip bar, you can get his or her respect straight away by saying, please, can you put your whip bar on? And they will know exactly, they will know that you know what you're talking about. So what this does is just a plate over where the wheels go in transit, or a sort of wheel plate, a hubcap for transit purposes. But this stops this rope from flicking out. And what happened on a site with UU contractor, or UU utility, United Utilities, is a driller was actually drilling, and the rope came out and took his thumb off. So it's for everyone's safety that this whip bar is in place. There are also some other things. Sometimes the drillers do forget, inverted commas, to put these little side stay bars on. Again, if you notice any of these are not in place, please ask the driller very kindly to put them on. Again, that will show your gravitas on site, and they will know that you know what you're talking about. So I will move on to the next slide. Any questions, please obviously put them in the chat box, and I'm very happy to answer them at the end, or through the. So Rory did actually have a picture of a cut down rig in someone's back garden. This is another picture of a cut down rig working in a basement of the old Colston Hall, which is now in Bristol, called the Beacon Tower. Yeah, it's all about communication, and Rory did touch on this. It's very important that you do talk to your drilling contractor about where you want the borehole, and the limiting factors. And he also said about measuring the height. The more height we've got, the larger the apex can be, the bigger the rig we can set it up, the faster we can drill. The faster we can drill, the quicker we can do the drilling, the faster we're out the way, the cheaper it is for your client or you. So the more space we have, the easier it is for us to drill, the faster we can do the job. This job on the left-hand side, this was a job I tendered and project managed, and the client actually, I asked the client, what's the access like? He told me it's about I want you working on a bridge deck, and it's about 3 meters wide. I said, absolutely fantastic, that's brilliant, thank you very much. We came with a full-size rig. However, what I didn't ask was, where exactly do you want that borehole within the bridge deck? I didn't ask the question, and he didn't tell me the answer, but he wanted it off center. So this was a site in London, and we had to mobilize a second rig to make sure that we got into the location that he wanted. So again, communication is vital in all of the things that we do. It was just not asking the right question at the right time. So that costs us money, unfortunately. This picture is obviously a small rotary rig. It's a Komatsu 205. It's a fantastic workhorse of the ground investigation industry. Most of our competitors have them. They're relatively small, relatively powerful. and can go into lots of different environments. One of the benefits of this type of drilling rig, it's got two drilling heads. One is a dynamic sampling hammer, which will just push through the drilling tubes, which are over here. Those are like casing, and you've got the rotary. Well, these isn't the right. These are the rotary barrels, but you've got a sort of casing and sort of vessel that will be hit with basically a big hammer, and that will go through sandy clay sands, but it needs to have a cohesive element to it. And if it's pure sand or pure gravels, it will struggle, and that's when we need our cable percussion rig. But if there is a little bit of a clay content in there, we should be able to use the dynamic sampling head, and then when we've got through what we class as the overburden or the sands, gravels and clays, we can then flip over to the rotary head and then use these rotary core barrels and go through using that. One of the reasons I chose this slide for you guys is so that you can see the amount of space that we need. This is a sort of typical amount of space, not particularly tiny, I do apologize, but they're sort of working sort of flat out on this pontoon. So it is a reasonable amount of space. And again, as I said before, the more space we have, the quicker we can drill, the easier we can drill, the cheaper it is for you at the end of the day. So this is one of the SPT hammers, and this will give us strength indication through the site as well. So yeah, that's that site, or that's the rotary, small rotary job. We can get a rotary job into some confined spaces. Again, some of you guys may have spills within buildings. You may need to investigate inside. You generally probably wouldn't want, it depends on how deep this spill has gone and the ground conditions, but we can use rotary inside the buildings. Obviously, you just need to be careful of the fumes. We need to make sure that we look at the fumes and the amount of air that's coming through here. We don't want to pollute the atmosphere. This is working inside a tunnel in Glasgow. I had the pleasure of working inside a tunnel over Hogmanay one year. So again, as long as we talk to each other, we can get our rigs or our drilling equipment wherever you like. Especially with contaminated ground, sonic drilling appears to be one of the better ways of recovering good quality samples of contamination. There is a little bit of disturbance on the edges of the sample of a sonic rig. There are two different types of method of recovery. One is in almost like a plastic sausage it's almost it's like it is like a sausage that comes out, or we can use rigid liner. So these rigs have actually got they've got a rigid liner, so that's quite helpful. Or we could have the sausage element, which is better for sands and gravels, but not so good for clays. So these are quite unique in the country. We've got 3 of these in our fleet, and they've got a sonic head and a rotary head. So once we're through the dense gravels, we can then flip over onto the rotary. So again, you only need 1 rig to get through 2 different types of strata. So it just saves a little bit on your mobilization cost. However, these sonic rigs aren't, they're literally the most expensive type of rig you can get on site. So be aware of that. Rory was also talking about soft ground conditions. Again, a lot of our sites could be in peat bogs. Hopefully you don't get many spills in there, but I'm just giving people the range of drilling plant that is out there. This has got a rotary rig on the back of it, so we can get into, this has a PSI of about 2 PSI, so there's a very small pressure on the ground, so we can get into some pretty soft areas. We've also got these Supercats, which are pretty awesome bits of kit. This one over here has a window sample rig on the back of it, and this one, I think this one is just a support vehicle for the cable percussion rig. We were working in an intertidal area, and it was very helpful to get in and out, and hopefully before the tide came in. Some of your investigation techniques, you may have a slope issue. There may be some sort of spill on a slope. So we need to investigate that. There are slope climbing rigs, and one of our sister companies called Central Alliance, they have slope climbing rigs, and they can get and investigate on a side of a slope. They've actually upgraded this. They've now got a couple of others as well, which have a platform rather than just a sort of free, well, without the platform on here. So, but again, they can work up to about 45-degree slope. And this one's actually got a cone penetration test head on it, whereas it can actually also have a rotary head on it. So as Rory said, he's mentioned window sampling already. There's a 65 kg drop weight in here, which hits metal tubes in the ground of reducing diameter, starting off at about 103, and then they mill and then they reduce down as we go deeper. 10 meters is probably a little bit high for normal. If it's very soft ground, yes, you can probably do that on a railway embankment, but on this particular site, this is sort of clay into chalk. We certainly did not get to 10 meters. So again, it's very, very difficult to know how deep we're going to get, but you can maximize the depth by putting some dynamic probe rods on the bottom of it. You won't get a sample, but you will be able to check the strength of the ground. So this is very, very typically used for contamination spills. We can do 5 or 6 holes in a day, depending on the amount of sampling or the amount of testing that's required. So it's very good for delineating contaminated sites, and I've used this a lot. So Rory also showed some rigs working inside. We have also got electric rigs. The rigs that he showed were diesel. This one is also a diesel. The mast does come off. So we can, if we have a difficult access site, we can put the power pack outside and we can work inside again to keep the fumes safe for us to work in. Yeah, so that's that one. Concrete coring. This is a very useful method. It's cheap and very rapid. We've got a small 50 ml barrel here. We can either drill it through the floor. So if there is some contamination that's gone underneath the floor slab, we want to check how far that's got. We can use the concrete coring to get through the floor slab, or this is actually behind the wall. So it's not really, it's more geotechnical rather than geoenvironmental, but you'll get the idea. And what we can do is then take a sample if we wanted to from behind that as well. What Rory didn't mention, that's a very cheap and rapid method of investigation is using a JCB or an excavator like this. This will really maximize your budget, and this particular site was contaminated with asbestos, and yeah, so that wasn't very nice digging. I did about 50 trial pits on a nuclear power station on that, and it wasn't very nice. I did lose a lot of weight because it was in the middle of summer as well. So, but again, it's very easy and effective, and we can get a huge amount of sample. One of the things that we do run into trouble, the larger the sample size, the more sample we need. So for our testing. So again, don't, like Rory said, you know, the more samples you take, the samples cost very minimal compared to not having enough samples and having to go back again. So please always specify more samples than you actually need, because it's still a hell of a lot cheaper than going back to site. Again, Rory has given us some pictures of the nice sampling, but I don't know quite how she's getting her samples out, but maybe a pump or something. So, but she's also doing some water sampling as well. This is just a very very quick slide just to highlight a few issues that sometimes we get a trowel pitting job specified on a car park, and would be very grateful if people didn't ask for trowel pitting on a car park for two reasons. One, it makes a huge amount of mess, and then we've got to reinstate it, and the landowner is generally never very happy with our reinstatement, whoever it may be. So my suggestion is window sampling through the hard standing to get that material sampled, which, you know, could easily be window sampled once you're through the slab. So literally a 1/2 meter by 1/2 meter small trowel pit, dig down to 1.2 and then do your window sampling through there. If you want some trowel pitting, then please go in the soft ground area over the back here. However, as over here, we've got some cobbles and of sort of limestone material. If we turned up with a window sample rig over here, we will struggle to get down through this. So again, if you turn up with just a window sample rig without a JCB, you are going to struggle to get through this. So yeah, it's imperative that you plan your work, have a look at the geology map, make sure you don't turn up with the wrong bit of kit. So this is not really, I mean, this is more geotechnical, but we have a lot of kit that we can test all of your geotechnical testing for. So I'm not going to spend too long. Any of your contamination material, we've got our sister company Envirolab, which will test any of the geoenvironmental testing that you require. But what we do have in our Castleford office, which is near Leeds, we have a red lab, so we can test any hydrocarbon impacted material, any asbestos impacted material, and do any testing that you require in a safe environment for our team. There is a premium for working in the red lab or having red samples, but it means that your samples can be reused on site rather than taken to a very expensive landfill tip. So if we can cap it and make it safe on site, as it's already there, and reuse it, then it's so much better than taking it off site. Again, like Rory, we can produce our logs there. We both use the same sort of GINT system, and it can all be exported in AGS. We can give that to your clients or yourselves, and you can do your design from those. So this is my little quick summary. Rory will do his desk study, make sure that we've had a look at all the available information, historic data, produce your CSM. Then we choose, well, part of the mobilization period and the tender period is choosing the right tool for the job, and then we report, and hopefully we do that all in one go. I'm just going to very, very briefly talk about a couple of the jobs that I worked on. We never know when we're going to get contamination, so we could start off as a geotechnical investigation looking at foundation design. All of a sudden we're digging some trowel pits and out pop a load of oil from this was actually a housing trade, well, it was a trading estate at the time, and then it was going to be developed into housing. So unfortunately we had to get a lot of remediation done, sort of almost as soon as we'd finished the ground investigation. So the skimmer was trying to take off any of the oil plume that was in the groundwater, and there was actually a pesticide spill in this as well. So we had pesticide and oil, just to add a little bit of flavor to it. This is little Eric, again in the middle of summer, baking hot in a nice Tyvex suit. And this was a old gasworks site. Again, we had a variety of different techniques to sample the contamination and delineate the contamination, but the quickest, easiest way was a JCB. So that's sort of what we had on that. So we interspersed trowel pitting with window sampling and shell and auger on this particular site. So, you know, we used a range of techniques on the same site. And I think that's probably my takeaway point to everybody here, is to use a range of techniques, because they all have benefits, and not everyone is the most appropriate. So I have one, my last slide is, we have a free guide to everybody, and you're more than welcome to download that. It's an engineer's quick reference guide. It's more on the geotechnical side, but it has got some geoenvironmental stuff in there. Please go to our website and download it. We won't be spamming you. And it's there for everyone's use. It's a lovely PDF copy. Hopefully some of you may have a hard copy if you're very lucky and have seen me in the last few years. So Rory, can you ask me some questions?
I think you've done such a sterling job. There's only one question at the moment. And that's from Francisco. So trial pits on an asbestos contaminated site seems challenging from a health and safety point of view. So what's your mitigation measures, or what mitigation measures were put in place to minimize risk?
I will tell you that. Unfortunately for me, I had to wear a full breathing mask at all times. We had to wet down the material, and I think, we just had to, when we were taking the samples, we had to put up signage around, because we were in open fields, so we had to make sure no one else, no dog walkers came up to us and things like that. So something else to think about is good signage, you yourself wearing, we had Tyvek overalls on, we had face masks, and we had to keep changing them, sort of plenty of those. I'm just trying to think. We had red, sort of double bagged asbestos, potentially asbestos contaminated material area, and we had, when we disposed of our Tyvek overalls, we put them in red bins, so we knew that that was contaminated material. So yes, we just had to be very careful of that. But again, speak to Rory or ourselves on that.
Very much, and I can definitely recommend the engineer's quick reference guide. I've got an electronic copy of it, and it's very good.
Good, Eric, that's great. Do you want to unshare your screen, and I
will unshare my screen? Yes. Stop share. Boom.
Good. Right. Okay. I'll share mine. So has anybody got any more questions, or are these two guys off the hook? Any questions? I think it's not. Well, I'd like to really thank you very much indeed, both Eric and Rory, for that really, really detailed and thorough presentation. I learned a lot about that. I'm sure most of the audience did. And thank you very much. I think, is that one new message? Sorry, what was that? Good. Oh, thank you very much, Catherine. So that she's asked the question I was going to come on to. Basically, this is being recorded, and I will get an edit through Zoom, and I will try to work out how to do it, and it will be put up on everyone who's registered will be emailed with an access to the link, and it will also be on our website. And if you go to www.ukeirespill.org/knowledge base, and you'll see that the recording will be there, and you'll be able to play the recording back. I mean, the idea of these is that if someone is a bit unsure or a bit rusty, they can pick up this webinar, play it as a sort of toolbox talk or a training, pre-deployment training, and they should pick up a lot of very useful information about how it should be done. And I really thank Rory and Eric for taking us through the whole operation. It was really useful, and I've learned a lot. So thank you very much indeed for that. Our next knowledge-based webinar is a week time, and it's spill response to biofuels. It will be delivered by Dr. John Burton of Oracle Environmental Experts. He, with ourselves, did quite a lot of research into the introduction of biofuels. I've been involved in biofuels since they were really first being talked about in 2002 through to 2006. and have really followed through helping customers manage how they use biofuels, but importantly, how we deal with incidents which involve biofuels. The first generation of biofuels really were just pure ethanol and FAME, fatty acid methyl ester. We've now into the second generation of biofuels with Shell GTL and hydrotreated vegetable oils, which in a sense are much better products than those that preceded them. We're still using a lot of ethanol, but actually what happens when the impact with the ground? And where we're using, in particular, we're using, say, 100% second generation biofuel as a complete replacement for diesel, which is commonly being used in generator supplies to reduce emissions. It is very green, but what happens when it spills? How do you deal with it? How do you with it? How do you deal with the initial spill, but also how do you deal with remediation? And it's a fascinating talk. Will take about an hour, but I would say if you're thinking about, if you want to broaden your knowledge into how to deal with a response to biofuels, that's the webinar to attend. So please go to follow the link on our website, go to Eventbrite. You'll see some promo on LinkedIn from tomorrow about this webinar, but it is a really, really good one. And I know that people from Offtech and New Kifta are going to be joining that webinar as well. Well, thank you very much indeed for joining us today. I hope you found it useful. We'll be finishing now, and do keep in touch and follow what we do on LinkedIn. And again, thank you to Eric and Rory. It's been a really useful, it's been a very interesting webinar. Thanks very much indeed for joining us, and have a good one. Bye-bye.
Thanks, Mark. Thanks, everyone.
Thank you.